Hey guys, hopefully this video is mostly a review of what we did last week on binomial probabilities. A lot of people struggled a little bit with those bookwork problems. The questions were kind of long and it was a little bit difficult to pick out the variables that you needed. So these are just going to be some extra practice questions. And also another note, the quizzes that was due last week, I went ahead and extended that an extra week. So if you want to go ahead and do this before you do the quizzes from last week, and just so you're a little bit more familiar with how to calculate these binomial probabilities, that may be a good idea and might improve your quizzes score a little bit. So there's nothing really new in this video other than I'm just going to help you get a little bit extra practice calculating these binomial probabilities. So the formula that we learned last week for binomial probability was this, the probability of any specific number was this NCR, and then it was P to the R, Q to the N minus R. Generally how you typed it in your calculator. It was basically the combination of N choose R, P to the R times Q to the N minus R. And in all of these, the N represents sort of the total number of trials, if you will. The R represents the number of successes. The P represents the probability of success. And the Q represented the probability of failure. So most of these problems are pretty basic, and they're going to just give you some more practice working with this formula. And again, hopefully that will improve your understanding, and also if you decide to go ahead and take the quizzes a little bit later. All right, so our first scenario here, also remember binomial probabilities, which is what these are, is basically either something happens or it doesn't. There's either a success or failure. There's not like a bunch of different options, either a success or a failure. So in this one, a fair coin is tossed 3 times. So 3 times, that's going to give you your N, your total amount. So I'm going to go ahead and write that N equals 3. What is the probability to the nearest thousandth of getting exactly 1 head? So a head is defined as a success. So what is the probability of getting 1 head? So that's going to be R. Number of successes would be 1. And then when we think about the P and the Q, it doesn't explicitly say it in this problem, but you know that you're flipping a fair coin. So the probability of a success, again, a head is what we define as a success in this case. Well, it's just 50-50, right? So we're going to say the probability of P is 0.5 and Q is also 0.5. Remember, Q is the probability of failure, which is also just 1 minus P, always. So once we've identified those, it's really just going to be plugging those into our formula on our calculator. So we're going to do 3, and then on your calculator, do that NCR 1. And then you're going to do your probability of success, which is 0.5. That's 1. To the R is 1 times 0.5, that's Q, to the 3 minus 1. So I'm going to go ahead and type that in. What you're going to do is 3 and then hit the math over to PRB. You'll see the NCR. So 3 NCR 1. Remember, the first number should always be bigger. So 3 NCR 1, that gives me 3 times 0.5 to the first times 0.5 to the second, because 3 minus 1 is 2. So I'm just going to hit times, and you can even type that all in at once if you want to, times 0.5 times 0.5 to the second. And that gives us 0.375. So if we were to just kind of translate what this means, that means you have a 37.5% chance of getting 1 head if you flip a coin 3 times. We're supposed to type this into the nearest thousandth. So we're not actually supposed to type it in as a percentage. We're going to type it as a decimal. Remember, this is tenths, hundredths, thousandths. So this, the third decimal place is always the thousandths. So we want to round to the nearest thousandth. So there's nothing after that 0.5, so we're just going to leave it at that 0.375. Right. Let's go ahead and try, this one's another coin one, so let's see if we can get it different. There we go. Delete the other stuff here, leave our formula up there. So this is Mr. and Mrs. Duran have a genetic history such that the probability of that child being born to them with a certain trait is 0.21. So maybe it's some sort of genetic trait like diabetes or something like that. So a certain trait is 0.21. They have 5 children. What is the probability that exactly 5 of their 5 children will have that trait? So that seems kind of rare, right? That if it's only 0.21, percent or 21% chance that's going to happen, the probability that all 5 of them would get that trait should be pretty low. So let's see what we get here. So first of all, N, total number of trials. Well, they're going to have 5 kids, so there's sort of 5 trials, right? R, the number of successes. Just look for the exactly, and that's pretty much going to tell you all there. So exactly 5. So all 5 of the total 5 have this trait. And then the probability of a success. So remember, it's either a success or failure. Success in this case is defined as having the trait. So that's 0.21. So then Q is going to be 1 minus 0.21 or 0.79. So then all we need to do is plug it in. Do 5. Do your NCR on your calculator. Choose 5. P, which is 0.21, to the R, which is 5, times 0.79, or Q, to the 5 minus 5. So that's just going to be 0 power. As long as you type this in correctly, again, you hit 5 and then math over to PRB, NCR 5 times 0.21 to the 5th times 0.79 to the 0. Now, anything to the 0 power is going to be 1, so it's just going to end up being the same. And this is what your answer looks like. 4.0841, and then a couple other things. And this is e to the negative 4. So hopefully you're able to recognize this. E to the negative 4, that's scientific notation. That's like times 10 to the negative 4, which tells you have to move this decimal over 4 places. So if we have this, we write it here, 4.08. That's actually all I really need. E to the negative 4, that means we have to move the decimal, move this, move 4 places left. So we get 1, 2, 3, 4. Fill in the zeros, we go 0, 0, 0. So this probability of this would be 0.0000408. So like I said at the outset, this should be a pretty low probability. And in fact, it's almost 0% probability because we're supposed to round to the nearest thousandth. Here we've got tens, hundredths, thousandths. So we're supposed to look next door from there. That's a 4, so we don't even round up. So the answer is actually going to be 0.000. So basically no chance that all 5 would have them. Very minuscule chance. But I guess we're just going to type this in. I'm actually type one in like this in Delta Math, so hopefully that works. You can probably just even do 0. There we go. And they said you could just do 0 as well. All right. So that's what they got. Same as 0. Okay, let's go ahead and maybe look at one more. Okay, so for this one, it just gives us a fraction instead of a decimal. It still works just fine. It's the same. All right, it says Mr. and Mrs. Duran have genetic history. The probability of a child being born to them with a certain trait now is 2/5. So same thing, except that its probability is 2/5. They're going to have 7 children now. Different family, I guess. So N is going to be then 7. R, how many successes? What's the probability of that? Exactly 6. So 6 out of the 7 have it. The probability of success is 2 out of 5 because 2 out of every 5 kids would have this. So I'm just going to write 2/5. If you want to just go ahead and make this a decimal, I suppose you could. It's the same as 0.4. And then Q would be 1 minus 2/5, so it would be 3/5 or 0.6. Either way you do that is fine. Probably easier to just type in the decimal as long as it's not something you have to round. So then plugging this into our formula, it's just 7 NCR 6, 0.4 to the 6, 0.6 to the 7 minus 6. Take a second and go ahead and do that. And I got 0.0172. And we're supposed to round to the nearest thousandth, so we want to look at the 7 and round up or down based on that one. It's not bigger, so we'll just keep it the same, 0.017. So pretty low chance. Again, if we were to look at this as a percentage, we move it over 2 places, it'd be a 1.7% chance that 6 out of the 7 would have it. But we want to type it in as a decimal, 0.017.